Hi, and welcome to the Pre-Algebra Tutor. And in this section, we're going to talk about adding and subtracting expressions. So what you're going to find when you start dealing with algebra is that you're going to have a lot of terms and things added together that have variables in them. And there's certain rules that basically tell you when you're allowed to add those things together and when you aren't. And so we're going to talk about that in this section. Now, I know you know how to add numbers together. I know you know how to add fractions together. What I'm talking about here when I talk about adding expressions is things that involve variables. And basically you're going to hear your teacher talk a lot about adding like terms or collecting like terms or simplifying like terms, something with the like terms in there. And what that means is in algebra, basically you're only allowed to add or subtract things together if they look similar to one another. You can sort of think of it in the real world. If I have baseballs over in this bucket over here and I have bananas in this bucket over here, yeah, I could dump them all on the table and I can add them all together as a collection of objects, but really, in order to truly add something together, they need to be the same type of thing. I need to have a bucket of bananas over here and some more bananas over here to be able to truly add them together and tell you how many total bananas I have. If they're different, in terms of algebra anyway, you're not allowed to add them together. And that's just because they're different objects, so think of it that way. So when I say you can add like terms together, what I'm talking about is the following. So if I'm going to have a little lecture for you on like terms, it's going to be something like this. If I have 4x and I try to add to it 6x, what I really have here, x is something. I don't know what x is, but just for a second, think about it as the number of water buffaloes. Well, here I have 4 times the number of water buffaloes, and here I have 6 times the number of water buffaloes, but in both cases I've got water buffaloes and water buffaloes, so I can add those things together. So when I do that, I can take the number in front and add them together. So 4 plus 6 is 10. Now, I'm still talking about water buffaloes, so I still need to keep the x along for the ride. The x doesn't go away, it's just that here I have 4 buckets of cotton, and here I have 6 more buckets of cotton, so I'm basically adding them together for 10 buckets of cotton. But these are what we call like terms. So another example would be, let's say, 8y plus, I'm adding to it, let's say negative 2y. Well, see, this term and this term both have a y. They look exactly the same, just the number in front is different. So I can add them together. 8 plus negative 2 is 6, but I still have to keep that y along for the ride because we're still talking about, whatever it is y represents. So in each case, this is like terms because the x looks the same. These are like terms because the y's look exactly the same. But if I had 7a squared and I add to that 2a squared, you see, here's the variable. It's squared, but over here I've got the same variable squared, so they're like terms. So I can add 7 plus 2 and give me 9a squared. As long as the variable looks exactly the same in both of my little terms here, I can collect these guys and add up the numbers and carry along my little variable. And it gets even more complicated if you wanted to have like a squared times b plus 2 times a squared b. These are also like terms because I have a squared b. I have a squared b. So I can add 2 plus the 1, giving me 3 times a squared b. All right. One final example just to show you how crazy this can get. What if I had 10 times x squared times y squared times z squared plus 3 times x squared times y squared times z squared. See, this term here, as far as the variables go, I have x squared, y squared, z squared. Okay, over here I have the same thing, x squared, y squared, z squared. So because they're exactly the same, letter for letter, exponent for exponent, I can add 10 plus 3, giving me 13. 13 what? 13 collections of whatever this is, x squared, y squared, z squared. So all of these are just examples, real world, everyday examples of what we call like terms.